All right. How do we start this? Direct substitution, Fanny. Good. And what do you get for direct substitution? When x goes to infinity, what expression do we get? Don't tell me undefined, right? We had a lot of that yesterday where people were telling me undefined, but remember, I don't care that the expression's undefined. I care about what the exact expression is, right? Now, 0 to infinity wouldn't be that bad. I think it's not quite 0 to infinity, Matri. 1 to the infinity, right? Right, because the 2 over x goes to 0, but I'm still left with that 1 plus. So I get 1 in the base and infinity up top. So 1 to the infinity. Okay, so now, yes, 1 to the infinity is undefined, right? It's not 1, it's not infinity, it's undefined. But 1 to the infinity tells us something very important, right? What does it tell us for this problem? We can use L'Hopital's rule, right? But we have to do, Emily said we can rearrange to use L'Hopital's rule. Matri said ln time exclamation point. You're very excited, right? So all of you are right. We have to use, we use L'Hopital's rule. But we need to do some stuff first. But we need to use logs to get a quotient first. Okay, so let's let L be this limit. Okay, so we've seen this many times now, right? The denominator would be a common denominator. We can rewrite 1 as a fraction, and the common denominator would be a common denominator. I don't necessarily think we should write 1 plus 2 over x with one denominator. I think it's actually easier if we leave it like 1 plus 2 over x. We'll see why when we take the derivative. So we take ln of both sides, and then we know that the 3x as a coefficient can now come out, sorry, as an exponent can now come outside of the ln as a coefficient. Now it's still not written as a quotient, so one more algebraic step. So the first factor x, I can write in the denominator as 1 over x. Right? And so now, so far, all I've done is take a logarithm and use algebra, right? And now let's make sure. If I substitute x going to infinity, if I did my algebra right, I should now have a L'Hopital appropriate form, right? So what do I get here? As x goes to infinity, this thing goes to 0, 2 over x. So I get ln of 1, which is 0. So I get 0 over, and 1 over x goes to 0. So I get 0 over 0. Okay, so now that I have now that I actually have a 0 over 0 form, I can use L'Hopital's rule. So what do we actually get up top and down below? Let's be careful, right? Down below, derivative of 1 over x is negative 1 over x squared. What about the numerator? What do I have to write in the numerator here for L'Hopital? Nice, let's see what Vernda said. So it looks like you're missing some parentheses, right? But I think I understand what you mean. So 3 times 1 over 1 plus 2 over x, right? You should have put that actually in parentheses when you typed it. Remember when you type things, you have to put that parentheses or else what you wrote was actually just 1 over 1 plus 2 over x, right? So just be careful of that. I know in Math Excel it actually makes it nice for you, so you can actually tell. And then again, it's not minus 2 over x squared. That really should be multiplication, right? So times chain rule times the derivative of the inside function. So times negative 2 over x squared. Okay, so all good. So now let's actually simplify this. So how does this actually simplify? Well, there's a negative 1 over x squared and a negative 1 over x squared. So those things actually cancel out, right? I still have that 2 left, right? Okay, so do you see that there's a negative 1 over x squared here and a negative 1 over x squared there. So those two common factors cancel out. So that means when those things actually cancel out, I'm left with, let's see, I still have the 3 and the 2. So I get 6 over 1 plus 2 over x, right? Everything else has canceled out. And now when I take as x goes to infinity, I get 6 over 1 plus 0, so I get 6. And now we pretty much have the answer. So if ln of my limit is 6, so the limit that I actually want is e to the 6. Okay? So it looked like that was just some extra algebra that messed you up a little bit there, right? Be careful of that. The negative x 1 over x squared should cancel out.